So in this video, I am going to do a couple problems from the Module 11 homework. I'm going to start with problem 4.6, number 25. And in this problem, we have a situation where two cars are driving. So car A is driving east towards an intersection. Car B has already gone through that intersection and is heading north. So I am going to start by just kind of drawing out an axis, because an axis is a nice way to demonstrate this set of axes. This origin right here is my intersection that the cars are going to drive through. Car A is heading east towards the intersection. So in other words, car A must be over here someplace. And car B has already gone through the intersection, so car B must be up here someplace. So I'm going to go ahead and mark in car A traveling in this direction, and I'll mark in car B, and car B is traveling in that direction. Then I'm going to go back and look at the rest of the problem. It says, at what rate is the distance between the cars changing? Okay, so the distance between the cars, I need to think about that. And I'm going to represent the distance between the cars with this line here. And since I'll be looking to see at what rate is that distance changing, I'm going to need to label that distance so that I can find the derivative of that distance so that I will know the rate at which that distance is changing. So I will use S as distance. Okay, so then let me go back to the problem again, and it says, at what rate is the distance between the cars changing at the instant? So it's a particular, that's why I need a derivative. I'm looking for at a particular instant when car A is 40 miles from the intersection. So car A is a distance of 40 miles from the intersection. And I'm going to label that distance X. So that's 40 miles. And traveling at 55 miles, wait a second, I think I'm reading the wrong problem. Traveling 50 miles per hour, that's what I thought. So it is traveling 50 miles per hour, remember, in this direction here. All right, and then it says car B is 30 miles, so obviously I'm not drawn to scale here. And I'm going to label this distance Y. And I am told that car B is traveling 60 miles per hour, again, away from that intersection. And so it wants to know, are the cars getting closer together or farther apart at this time? So we want to find first, at what rate is the distance between the cars changing? And then we want to know, are the cars getting farther apart or closer together at that particular time? And the time, what they mean by that is when car A is 40 miles from the intersection and car B is exactly 30 miles from the intersection. Okay, so the first thing, now I have the problem kind of set up for me and I know what I'm looking for. So the first thing I'm going to do here is make this relationship for S. I need to have some way of expressing S. So I'm going to use Pythagorean's theorem for that. So I know S squared equals x squared plus y squared from Pythagorean's theorem. And so S squared equals 30 squared plus 40 squared, which happens to be, gives us that S is equal to 50. So for those of you who remember, that's a 3, 4, 5 triangle. If you don't remember, you can just plug that into decimal serial calculator and end up with S equaling 50 at the time when A is 40 miles away and B is 30 miles away. So S is 50. So, but now I'm looking for the derivative with respect to time. And so I'm going to go back to my equation here and take the derivative of that equation. So I'll be taking the derivative of both sides with respect to t. And so let me get a new color for that. I'll use this one. So in other words, I need to take this term with the derivative of that term with respect to t, and the same thing with each of those terms. And when I do that, I'll end up with 2s ds dt equals 2x dx dt plus 2y dy dt. Okay, because that's using the chain rule, so you remember that from when we learned about implicit differentiation in our last unit. Okay, so now I just need to plug in some values here and then find out what ds dt is, because ds dt is what I'm looking for, and I know everything else. So I'm going to start inserting some values here. So I'll have 2. S is, we just found out, 50. So 2 times 50 ds dt is equal to 2. And x is 40. We know we're 40 miles away from the intersection. And the dx dt is actually a negative 50. And the reason it's negative is because I'm getting closer to the intersection. And so that distance between me and the intersection is reducing. It's getting smaller. And so it's getting smaller actually by 50 miles per hour. So I know that that is a negative. Then I have plus 2 times y, which is 30 at that moment. And dy dt is positive 60 miles per hour because B is going away from the intersection. So that 30 is actually increasing as time goes on, and it's increasing at a rate of actually 60 miles per hour. So that would be a positive 60. Okay. And so then if we, this would give me 100, ds dt is equal to, let's see, what do we have here? Negative 4,000 plus 3,600. And so then ds dt is equal to negative 400 over 100, which is negative 4. And our units would be ds dt is negative 4 miles per hour. And so since that derivative is negative, what's that telling us is that S is decreasing. That distance between points A and point B, that distance there, at the moment in time when A is sitting 40 miles away and B is already 30 miles past the intersection, that distance S is decreasing by 4 miles per hour. So the cars are getting closer together. All right, let's look at one more problem. We'll look at 4.6, number 29. And in this problem, we are told that an item cost $500 at time equals 0, and it costs P dollars in year T. So it tells us that inflation is R% per year, and the price is given by this formula here, which is P equals 500 e to the RT over 100. Okay. And then part A says, if R is a constant, at what rate is the price rising in dollars per year? Okay, so that is straightforward. Find P prime with respect to T. T is our variable, R is a constant. And so that would give us P prime is equal to 500 e to the RT over 100. And then using the chain rule and the fact that R is a constant, we would have R over 100 multiplied in there. So that is our derivative. I can kind of simplify that. P prime is 5r e to the rt over 100. And so it says, if r is a constant, at what rate is the price increasing initially? So p prime at 0 turns out to be simply when we plug in t equals 0, e to the 0 becomes 1, and so then it becomes 5r dollars per year. And then p prime part 2 of A asks for after 2 years. So P prime at 2 is equal to 5R e to the 2R over 100, which comes out to be 5R e to the R over 50, and that's dollars per year. Okay, so that took care of part A. And notice we can't actually get just like a final value there because we don't know what R is. We just know R is a constant, and so we have to have things in terms of R. So now for part B, however, part B is saying, well, suppose R is increasing, okay, by 0.3 per year, percent per year, when R is 4 and T is 2 per year. So R is increasing 0.3 per year when R equals 4 and T equals 2. Okay, so it wants to know at what rate in dollars per year is the price increasing at that time. So again, we're taking the derivative with respect to T, but now R is no longer a constant. So we have to think about that when we're applying our chain rule. So start off, P prime is equal to 500 and then e to the rt over 100. But now when we apply the chain rule to this section right here, since there's two variables in there, we actually have to use the product rule to find the derivative of that. When we do that, we would get you take the derivative of the first term, so the derivative of r with respect to t is going to be dr dt, and then you multiply that by the second term, which is t, then, and that's all over 100, plus now we take the first term, which is r, and multiply it by the derivative of the second term with respect to t, of course. And the derivative of the second term with respect to t is just 1. So we end up with r over 100 over here. Okay, so now we can clean this up just a little bit. So we have the 500 e to the rt over 100 multiplied by dr dt, t plus r all over 100. Just combined those two fractions into one. And now we have to see, okay, well, we're given some values. We're actually asked for when time is 2 and when r is 4, and we know that r is increasing by 0.3 per year. So what I'm actually looking for here now is p prime at 2, because t is my 2, equals 500 times e to the number r is 4 and t is 2. So 4 times 2 is 8. Actually, I'll just leave it here so when you're looking at it, you can see what I've done. 4 times 2 over 100. All that is multiplied by the dr dt is 0.3. times 2, R is 4, all over 100. And you can just really just plug that straight into your calculator or decimals. Make sure you have the parentheses in the right place. And you find out that then the derivative at 2 is $24.92 per year at 2 years when R is 4 and R is increasing by 0.3 per year.